Greetings all LinkedIn community. Today, I would like to share my learning experience with the Kafka mTLS communication, how it happens between controller and broker. Controller has to prove its identity when it communicating to the broker, whereas on the same, broker has to prove its identity when it's communicating to the controller while establishing the initial session. So these are the two nodes virtual machines where broker 1 and broker 2 are running, and this is my host bare metal, and this is where I have my own trust store with the name Srinivas so that I could visualize the things. So for creating your own certificate authority, first you should create a CA private key. This is what is a CA private key. Then a self-signed certificate. Using these two, you can create your own CA trust store. Can be created with the open SSL, which is Apache from the Apache open source foundation. Going deeper, let's see who issued this certificate. To get all those details, this is the command you need to execute. So this certificate was issued by me, and the location details, if you see this, I'm in Atlanta, Georgia state, and the organization unit I kept it as one infra for my lab, and the RSA algorithm that is being used, the digital signature, that's it. So basically a certificate contains the subject alternative name, and then it will contain the public certificate as well as the digital signature. This is all a certificate typically have, and this is a command you can use to know the to get the public key from the certificate which you created for your trust store authority. So typically this is 392 characters in length, a standard length binary 64. We have seen what is present in the certificate. Let's see what is present in the trust store. Let me enter the password here. Okay, if you see the trust store and also having the same certificate which you have created, right? Srinivas CA certificate to scare. As CA trust store contains the same CA cert itself, then what is the need for the trust store? There are two important things here. A TLS libraries of Kafka. The good part is Kafka is developed using Java. For the current use case, Kafka is written in Java, and all TLS mTLS is handled by the Java Secure Socket extension. It will read the certificates from the JKS or PKCS 12 trust store. It cannot read the raw certificates directly. That's the reason you need to have a trust store. Now come back and let's take a look at it. How many components we are going to connect? In the cluster, I'm having one controller and two brokers, right? For each of the component controller, you need to have a dedicated private key and you need to have a dedicated certificate. And this certificate will be signed by the CA certificate using the private key of the component. Okay, same likewise, if you go to the broker 1 or broker 2, it will have its own certificates, but again these are keys actually, so these will be stored in the key store. Only the CA certificate will be stored in the trust store and the rest will be stored in the key stores. Each component will have its own dedicated key store for the controller, key store for the broker, if you see the key store for the broker too. And same concept here. Why do you need a key store? Because Java cannot read the raw certificates directly, and it uses the JSSC TLS libraries to fetch the keys from the key store. You come into the crux of the mutual authentication. Broker 1 presents its certificate from its key store. Likewise, controller also will present its certificate from the controller key store. Okay, nothing will leave from the system, only the certificate will leave from the system. The controller validates that certificate using the CS certificate in its own trust store, right? Do you have its trust store? This is what is valid. Then the broker or controller also presents the certificate, and that certificate will be valid by the party which whom you are requesting against the CA trust store present on that node. Okay, in that way, when a controller communicates to the broker, controller goes with the certificate. That certificate will be validated by the broker in its broker key store. Likewise, when a broker communicates to the controller, broker will come and presents its certificate from the key store, and controller will validate it against the trust store. Ultimately, the trust store, whoever is issued the certificate, should validate the signature. Let's go a bit deeper. Execute the SSL handshake from controller to broker. Okay, let's do the quick mTLS handshake test. Okay, the SSL mTLS handshake test was successful from Kafka controller to the Kafka broker. Let's take a bit dive into this. So, while making a secured SSL connection, I used the controller certificate. Okay, this is the only one that leaves this host, but I also need to provide a key and CA cert, which is available in the trust store, right? None of these will leave out of my host while making a connection to the broker. Only the CRT, the certificate, leaves it. But why do I need the controller key? I need to have the controller key because using this controller key only, I can sign this certificate and send it to the broker. Okay, that's needed, but it will not leave it. In response to my request, what I got it from the broker, since it is a mTLS, I got the broker certificate back. Right, did you see this certificate chain? It's saying, so I got the certificate back from the broker certificate. So I need to validate the broker certificate again using the certificate authority that is present or hosted on my controller machine, right? So controller is proving its identity, broker is proving its identity, though the communication is initiated, the request is initiated from the host, from the client, from the controller, right? All these are same here. And but broker is also sending its certificate in response rather than just accepting or validating the controller is genuine, right? That's why it's a mutual, and this is needed every time we when you establish a new connection. So in a nutshell, in mTLS, my Kafka controller presents a signed certificate by the internal CA. The broker verifies its trust store, and then the broker returns its own certificate, which the controller verifies using the same CA trust anchor. So both sides mutually prove identity using the signed certificate, right? That's the core of this secure distributed systems. Just cat into the server properties of the broker here. You see this, all the SSL configurations are provided here. Right now on the listener side, I have both the plain text non-secured communication as well as the secured communication. Since now I have enabled secured mode of communication, I can take this guy out here. SSL, just going to keep the SSL mode alone.